Hi and welcome to this lesson on pressure in gases. Have a go at the starter and pause the video for a moment and then we'll go through it. Okay, so factors that affect how much pressure a person exerts on the floor. We are interested in the weight of the person, and you should have said the surface area in contact with the floor. Okay, so those are two key factors. Because pressure is force divided by area. The units of pressure are either newtons per meter squared or pascals. You can also use newtons per centimetre squared, but that is not equivalent to a pascal. 1 pascal is equal to 1 newton per metre squared. Okay, have a go at these three questions using the equation, and then we'll go through them in a moment. Pause the video while you do them. Okay, so for question 1, you should have done 20 divided by 50, and that should give you an answer of 0.4 newtons per centimetre squared. For question 2, what's the pressure when 600 Newton person wears shoes with a base of 75 centimetres squared? So we need to do 600 divided by 75, and that gives us 8 newtons per centimetre squared. And then for question 3, you're asked how much force is needed to create a pressure of 1 newton per metre squared on a syringe with an area of 1 centimetre squared. So first of all, we're after force this time, so we've got to rearrange the equation and we get force as pressure times area. Now, the next thing we need to consider, we've got a pressure of 1 newton per metre squared, but our area is in centimetres squared. So we need to convert the centimetre squared into metre squared for this. 1 centimetre squared is 0.0001 metre squared. So we do 1 times 0.0001, and that gives us 0.0001 Newton. Okay, so gas pressure. Gas pressure is created when gas particles collide with the walls of the container that they're in. We're not interested in the collisions with other particles, just with the walls of the container. And we can compress or expand by changing the pressure. And that pressure produces a net force that's at right angles to the surface. Now, the key law with regards to pressure is called Boyle's law. And Boyle's law tells us that if a gas is at a constant temperature, the pressure is inversely proportional to the volume, that should say. Pressure is inversely proportional to the volume. Okay, so PV equals a constant. Pressure times volume is equal to a constant as long as temperature is a constant. What does inversely proportional mean? How can we check for it? Well, if you've got a table of results like this, the best way of checking for it is working out the pressure times the volume in each case. So we've got 10 on the first one, 10 on the second one, 9.9 for pressure of 3, 10 again, 10 again. You can see a pattern starting to form. Now, if something's inversely proportional, one thing times the other thing is always going to be a constant value. Now, here you'll see that we're starting to deviate a little bit more from the straight 10. That's because the numbers for the volume have been rounded. Okay, so if those numbers hadn't been rounded, these numbers would all be slap bang on 10. It is a rounding issue. You can see that there's some wobble, but generally, those are all constant. If you have a graph of inverse proportionality, what does that look like? Well, here's a graph of volume against pressure. You'll see it's a curve. It never touches the axes. And if you take any 2 points on that graph and you multiply the y coordinate and the x coordinate of those 2 points, you're going to get the same answer. So A times B is equal to C times D in that case. Okay, if we want to increase the energy of a gas, we do work on it by applying a force to it, and that can increase the internal energy, and that can also result in an increase in the temperature. And if the temperature increases, remember, Boyle's law doesn't work. Okay, have a go at the questions, and I'll see you next time.